Bitwise operators are operators that work directly on the binary bit-level representation of integers. They perform operations such as AND, OR, XOR, NOT, and bit shifting by comparing or manipulating individual bits in numbers. These operators are commonly used in low-level programming, performance optimization, and tasks like masking, setting, or toggling specific bits. The bitwise AND operator compares two numbers bit by bit and produces a result where each bit is set to 1 only if the corresponding bits in both operands are 1. If either of the bits is 0, the resulting bit is 0. It is commonly used to mask bits, meaning to extract or check specific bits within a number. The bitwise OR operator compares two numbers bit by bit and produces a result where each bit is set to 1 if at least one of the corresponding bits in the operand is 1. A bit becomes 0 only when both bits are 0. It is often used to set specific bits in a value without affecting the others. The bitwise XOR exclusive OR operator compares two numbers bit by bit and sets each result bit to 1 only if the corresponding bits are different. If both bits are the same, either 0 and 0 or 1 and 1, the result bit is 0. It is commonly used for toggling bits, simple encryption, and detecting differences between values. The bitwise NOT operator flips every bit in a number, turning zeros into ones and ones into zeros. This operation produces the bitwise complement of the value. And in most programming languages, it is also affects the sign because numbers are stored using two complements representation. As a result, applying NOT to a number yields a value equal to minus n plus 1. In this simple Java example, we will turn characters into uppercase version. First, we are declaring char variable. In for loop, we are iterating from 0 to 9 and adding integer to char. By adding integer values and casting it to char, we are getting another character from the alphabet in ASCII encoding standard. A char represents a single 16-bit Unicode character in Java, so by using AND operator with an integer value that has 0 at 6th position and 1 at the rest it, we will turn this position to 0 and leave the rest unchanged. This will lower integer value to match characters of uppercase version. In the second Java example, we will do the opposite. In this case, we will start with uppercase A letter and iterate 10 times. To get lowercase character, we have to use integer value 32 that in binary format has only one number at 6th position. Or leave the rest unchanged and turn 1 at 6th position, so we'll increase value to get lowercase representation from ASCII table. In other words, we'll increase value from 65 to 97 and so on. 65 in this case is uppercase A and 97 is lowercase a. In our last example, I will show you how to use XOR for a very simple encoding and decoding messages. For this purpose, let's define string variables. First with a message to encode, next with results of decoding and encoding, and last with our key. This key has such a binary representation. Using XOR will switch every unmatching value to 1 and every matching to 0. By doing so, we can do the reverse later on by using the same key on our encoded text. In this algorithm, we are basically extracting each character from the string, processing it with XOR and our key, and assigning back to the results variable string. The coding process is doing the opposite. It's taking previously produced ones and zeros and flipping the bit to the previous form. That will be all in our Bitwise operators journey. See you in the next one and subscribe for more videos like this one.